Okay. All right. So, anyways, back to this here. Weakest forces, strongest forces, water somewhere in the middle. So if we were to draw little dots above them to represent vapor, how would I draw the three differently? Good. Propanol would have a lot of dots. Weak forces, it evaporates very easily. Very good. High vapor pressure because the particles are colliding. Good. What about water and ethanoic acid? Any thoughts there?
Water would have like a medium amount.
A medium amount, so maybe like 1, 2, 3, 4, 5, 6, 7, 8. Less than propanol, obviously. You don't have to count, but less than propanol. Ethanoic acid?
I mean the least.
Yeah, like 2 or 3. Okay? So the concept there is, can you visualize what we're learning, right? So I had you guys, kind of hold hands. Those are forces. Remember, the surface only evaporates because of the forces. There's less forces at the surface. Surface area, we talked about all that. But anyways, this is a good visual. So I'm really stressing this chart in terms of, can you tell me which one has the weakest forces, strongest forces? Now, we're going to get to the homework in 1 minute. But first, what did we learn last week about the dotted line? What happens there? Raise your hand. Raise your hands. Mike?
Where it begins to boil.
Right, that's called the normal boiling point because it's at standard pressure, normal boiling point. This one's about 55, about 80, 100, about 100 for water, right? And 117, 118 for ethanoic acid. So if you go to number 50 again real quick, there's 2 ways to answer this question. You can understand it by saying, all right, it's ethanoic acid. Why? Because it has the lowest vapor pressure. At any temp, it's the lowest vapor pressure. That's one way to answer it. And the second is it has the highest boiling point. If it takes more energy to boil, it's stronger. So anyways, I'm just using that to review. All right, let's go over the homework quick, and then I gotta show you how to boil water without heating it up, even though I'm cheating a little bit. Here we go. So I'm gonna go through these kind of quick. You compared, hopefully you're good with this. Let me turn that off. Number 1, to double the kinetic energy, we have to first change 27 to Kelvin by adding it to 273. What's 273 plus 27? 300, so the answer is B. You have to increase to 600 K. Right, you have to double the temperature on the Kelvin scale to double the kinetic energy. Number 2, which sequence has increasing kinetic energy? Matt Payne, what moves faster, solids, liquids, or gas? Which particles move fastest?
Gas moved the fastest.
Good. Which one moves the slowest?
Solids.
Good. So what's the answer?
D.
D. Solid has the least amount of kinetic energy. They sit there and vibrate. Liquid a little bit more. They can move around a little bit because their forces are weakened. And then gas, forces are being broken. Particles bounce around all over. Lots of kinetic energy. All right, 3. Which is not part of the kinetic theory. Morgan Thomas, what do you think?
C.
C, yeah. They all, the sample would have the same average kinetic, but not individual particles. So some particles have more than others. When they collide, they transfer that energy. Right, so 3 was C. 4. Okay. Hopefully you were able to follow how to answer this here. You got A and B down here. Look up here quick. You got A and B here, and then these questions were for that. If you read it, you should have understood that. So which flask has the lowest vapor pressure? Give a reason. Hannah, what do you think?
I think flask B has the lower because the liquid in the tube is lower than in flask A.
Very good. Now it's kind of a crappy copy. I probably should have actually gone in here and put more dots inside B. So B is supposed to look kind of like this, and A looks kind of like that. So if you look at this, what happens here is the vapor goes up and then pushes the liquid. Yeah, they can.
And you're
I know Trevor Burdenside's not here, so.
all right.
So my announcement didn't go on, so that's cool. So I'm gonna have to have a meeting Thursday.
Okay.
The problem is we have open gyms. We're supposed to have them every day this week.
Every day
so
this week.
We're just gonna tell the kids and whoever can show up.
Okay.
Anyways.
Go on, if you go on the school website under athletics, and then the code of conduct will come up, and at the end is a page.
Yeah, I can print that off.
I print it off, and then what I just do is I just write on there and tell the kids that they read the code of conduct online.
Okay.
And they sign it.
All right.
So that they don't have to.
Yeah,
They
so we don't
need
have to have
paper
a
copy.
million-
We can provide them with a
Right,
paper copy,
got
so you
it.
don't have to make a million copies.
All right. Yeah. So we're gonna do that Thursday, I guess.
Code of conduct. Yeah,
Thanks.
we're gonna have our meeting Thursday also.
All right.
So we'll have dueling meetings.
Basketball Thursday.
Yes.
All right. Thanks, boss.
Anytime.
All right. So again, vapor is produced, it pushes the liquid up, right? So she said it says which one has the lowest vapor pressure. B is correct because the liquid is not being pushed as high, so there's less vapor pushing it. 5. Which one has a higher temp? Oh, I don't know. Watson, what do you think?
A.
Yes, because it probably has more vapor pushing that liquid further up in that U-tube, it's called. So the vapor is pushing on that liquid, meaning there's more vapor, meaning it's probably warmer. If it's warmer, it evaporates faster. And I should have had you skip 6. That's not that easy to understand. Actually, what you do is you subtract the level of where the liquid started from where the liquid ended, and then you can calculate the vapor pressure from that. Don't worry about that too much. 7. What's the normal boiling point using that chart? What's the normal boiling point of ethanol, Leah? You gotta speak up a little bit more. 70? Is that what you said? No. Close to 80, very good. I would say a little, maybe 79 degrees or 80 degrees. It's where ethanol crosses that 101.3. All right, can chloroform be heated to 90 in an open container? Adam?
No.
Why?
Because it would evaporate.
Very good. The highest temperature it can reach on that chart is 60, 61, 62. So 90, it's going to be vapor. Very good. To what temperature must water be heated so its vapor pressure equals the vapor pressure of ethanol at 60? You know what? I should really show you guys how to do this one. Bear with me for a second. Lights, please. I'm sure a lot of you got it right, but I want to explain it anyway, because this is kind of a Regents level question. Otherwise, it's a little bit easier. All right. Let's see here. Where's my... All right. Let's see. Nicole, can you go read that temperature again? Morning.
Can I borrow your stapler?
You can. Can you see my spinach?
What?
My spinach. I'm Popeye.
Oh.
Yeah, it's Popeye's a little old school. I don't know if everybody around here is going to know that.
Thank you.
No, thanks. Okay.
Yes.
Oh, sorry, what's it say? Can you turn the hot plate off, please? As soon as we're done going over the homework, I'll show you how to boil water that isn't at 100 degrees. And then we'll relate it to table H, then we're going to move on. All right, here we go. So, the reason I'm taking time to do this is because it's really important to understand how to answer this question. All right, question wants to know, what temperature must water be heated to so it has the same vapor pressure of ethanol at 60? Can anyone, first of all, give me the answer? Ariel, what do you think? I haven't talked to you today. 82, let's find out. So we go to 60 degrees and we go up to ethanol. Vapor pressure at ethanol is about 50. Would we agree? Yes? Watson, you with me? Can you focus? Stand up my muscles. So at 60 degrees, ethanol, about 50 kPa. Okay. So if water is heated to about 80, you said 82? 82, that's about 50 kPa. I would agree. Good job. That's how we answer that question. If every... Yeah, around 85, sure. I mean, 85 would be, yeah. Between 80 and 85 would be probably good error, margin of error there. So between 80 and 85. So if everyone got it right, good for you. If not, hopefully I clarified it. So again, you look up whatever one they ask about, that's ethanol, and then just keep that same line and go over to water and read it. So it's about 80, between 80 and 85. All right. 10. In an open container, the rate of evaporation equals, no, that's false. I don't know, how do we answer this here?
You're supposed to fix it, I think.
So false, if it's false.
It's a closed.
Oh, okay, so, yeah. So 10 would be, so the right way would be, because, oh no, there is no.
Yeah, they were confusing.
All right, how about this? If it's false, we're just going to move on. So 10 is false. It has to be a closed container for that to happen. Moving on. 11. Water boils at temperature below 100 on top of a mountain because atmospheric pressure. Yeah, that is true. So 11, the whole statement is true. And we're going to do that with the vacuum chamber today and then relate that to table H. 12, temperature of a substance is always increased as heat is added to the substance. Yes, because the average kinetic energy increase. Yeah, so 12 is correct. If you give it energy or temperature, give it heat, temperature goes up, kinetic energy goes up. Good. Solids have a fixed volume. Yes, because particles in a solid cannot move. That's not true. Not really. I think they probably are. They want you to say yes, that is accurate. But what do they can move? What do they do? They vibrate, but they can't move around. So maybe they should say they have a fixed volume because particles in a solid cannot move around, but they do vibrate. I wish there was a little bit better than that. Gases are more compressible than liquids. Yes, because there's more space between the particles. True. All of that is true. So 14 is true. All right. Now, the back of this is due tomorrow. Okay? Keep your notes out. But let's come back. Go get some glasses on, please, just in case things happen.